Okay, so we're back with part two. Um, Partially because that's all I really wanted to talk about in part one. And the second thing is I don't have great software for video recording or editing because I don't know what I'm doing. Surprise! Okay, so if you've been waiting to find out what eutrophication is, here it is. When these pollutants like phosphates or nitrogen in some cases gets into a water system like a lake, it's going to cause algae to grow and grow and grow, the primary producers to grow out of control, and it's going to lower the amount of dissolved oxygen in the water, and it's actually going to kill off a lot of the fish. So that's associated with algal blooms, which is algae growing really fast. Another example of pollution into our local water systems is your gas is leaking in your car, oil is leaking, and it gets into the lake or river. If you maybe remember, maybe you've heard this before, point source. Like you can point, like there it is, it's coming out of that pipe right there. Something like eutrophication often is non-point source pollution. You can't tell where this came from. You have no idea. There could be many farms in the area. They could all be contributing to it. So just kind of clearing that up a little bit for you. So what I wanted to talk about in part two is a little bit more about water use and management. Okay, that's kind of important. So we looked at the water cycle, where water is on Earth, and we kind of mentioned about sustainability and stewardship with our water. So let's look at that. So like residential water use, that's talking about your daily water use, when you use water to make your coffee in your giant cup. Or you take a shower. By the way, shower and brush your teeth twice a day. These are good things for you. Okay, when you flush the toilet, when you wash the dishes, all of these are examples of residential water use. So what happens to our water? Water is treated to make it potable. That's a fancy word that means drinkable. So it's safe to drink. The bottled water that you have, that you might buy from the store, is potable. That we have somewhere over there. There's like a big thing of them. So we want to treat our water because it destroys things like pathogens. That's like bad bacteria that could make us sick. That's why you don't want to just cup your hands and drink out of the stream or the creek near your house. Okay, it's not potable water. There's actually a really cool invention called the life straw. It looks like a straw, like a cylinder, like it's kind of bigger around than a normal straw, and you can drink kind of water that looks like my coffee. Can't see it because of the way my webcam is, but it's kind of brown. And it will filter out all of the dirt and algae and pathogens that would potentially parasites that would make it dangerous for someone to drink that water. So again, what's a pathogen? It's an organism that creates illness or can cause disease. Bacteria is an example. So we don't want those in our water. That's why they go to a water treatment plant. There was an act in the 70s, before even I was born, I'm not that old, sorry, that was designed to improve water quality in our country. So that's why we have safe, clean water. We should. So our use as residential, we take about 19% out of the 100% of water that's used in a day. Industries, so factories and things like that, they use about the same amount as all the individual people, 19% of the water use in the world. And most of that water is used to cool down a power plant. So how does that work? Well, let's imagine we have like a nuclear power plant. Those nuclear reactions are extremely hot. They generate heat that will heat up the water and spin a turbine and generate electricity. I'm sure you could look up really quickly on YouTube, how does a nuclear power generator work, and you can find little cartoons that explain it better than I could. But those things need to also be cooled because things could overheat and could have disastrous consequences. So water is used in helping in the production of energy and also cooling down the power plants. That's a lot of water use. And then the largest use of water around the world is through agriculture. So you can see here I have some information where it says 1 ear of corn. So to grow 1 ear of corn over a growing season, it's going to require 80 gallons or 300 liters of water. So it doesn't mean, okay, I'm just going to pour 80 gallons onto the seed and I'm fine. Over the growing season, remember, like you start with a little seed and you plant it in the ground and you have to water it in the sun and photosynthesis and then pollination, and then you have like a fruit or a vegetable. So over the growing season, just 1 ear of corn, as an approximate, is going to need 80 gallons of water. That's a lot. That's as much as one person uses each day. That's a lot of water we are using, by the way. So 60%, 67%, of our Earth's water is used for agriculture, which we need. I mean, we need to eat. Okay, so that's a lot of water. And a plant only uses 80% of the water it takes in. That's fairly efficient, just saying, plants. So the other part is wasted. It goes back into the ground. It runs off. Now, if we put fertilizer on our soil and some of that runs off, that's where you go back to that picture of that green lake that I showed you. You get that eutrophication. So these really, really large farms, some of the fertilizer does get washed off into our waterways and into our lakes and then causes fish to die off. So one point that I want to make sure you understand when you're studying environmental science or biology is that everything is connected. Like whether you can see it directly or not. Like you might be like, well, I'm not connected to an elephant. No, you're not like sitting there, and maybe you are, but you're not directly connected to an elephant like they're in the room with you. But the actions that we take and the things that we vote for affect living things and other people across the world. Okay, we're no longer just stuck in our own house or our own state or our own country. We're not, like, because of the internet, because of just how things are nowadays, we are a global civilization in a way. So we have to realize everything we do is connected. And hopefully you can see through water how we're all connected to each other. I'm going to do this, and I still don't know how to edit, so this might be in there. Alright, so let's take a minute and just look at water conservation. In agriculture, that means farming. Industry, those are like factories and corporations. And at home. So on farms, some water is lost due to evaporation, seepage, which means it goes into the ground and runs off, which means it literally runs off the edge. There are some ways of irrigating, that means bringing water from the source to the plant, that stop that, like drip irrigation. So they'll have like a slow drip. So the plant will be fed a slow amount of water instead of someone coming with a hose or like a watering can and just dumping a bunch of water on. Some of that water gets lost if you do it that way. This causes less water to be lost. Here's a positive, because we need some positive, uplifting news. Some industries are now recycling their wastewater instead of just using fresh, cool water. So they'll have tanks or reservoirs where they use some water to cool off their machinery. They'll let that build up, cool down, and they'll recycle that and use that water instead of putting it back into the environment. For example, if you use some water to cool, like these nuclear reactors, it doesn't touch a nuclear reactor. It's still water, but it's very hot, practically boiling. And then they'll just throw that right back in the river. Well, anything living near where that is just going to get boiled. So even adding hot, very hot water to a river system is bad. So we have to be more conscious of these things and how they affect the environment, because that's going to turn around and affect us. So again, these are things that an individual can't do. These are things that corporations, industries need to do, and maybe government needs to regulate and make them do these things if we ask for it. So maybe you think, well, I want to help. How can I conserve some water at home so I'm not wasting this resource that's not, I don't want to say it's unlimited, because it is limited, but it recycles itself. So you know what I mean. Okay, you can take shorter showers. If you're in the shower, girl, if you're in the shower for over an hour, you don't need to be in the shower for that long. You really don't. I would say every day set a timer for less and less and less and less time, so, until you can manage your time in the shower. Okay? That's one thing you can do if you want to really help the earth. If you brush your teeth twice a day. You want your teeth to be healthy your whole life. Don't leave the water running. It might sound silly, but it's very simple. Some people say, okay, we'll fill up the sink and push the little thing down and use that to like wash your face instead of leaving the water running. You will use less water. If you're like, oh man, I gotta wash my clothes, don't just put 2 things in there. Wait until you have a full load, so that way you're not using extra water. Some washing machines are like smarter and can sense how much water is in there, or how much clothes are in there. Gosh, couldn't get that out. But you still want to make it more full because water will be wasted otherwise. How many of us can afford to get a new toilet? They're expensive. You can put something in the tank in the back of the toilet, like a brick, that will actually make your toilet use less water. It'll still flush down all your pee-pee and but it'll just use less water. You can use a low-flow shower head. Some of them are not good and kind of painful. And I mean, sometimes we don't have the money to be doing those things. But the first 3 things are all things that we can do that would really help. If everyone did that little bit, it would help. So it's something to think about. So remember back to part 1, I told you that most of Earth's water is salt water, which we can't drink. We can't make use of. You can't put that on a plant, just like we can't drink it. A plant also can't drink that. So what is desalinization? It's the process of removing salt from the water. So how do they do that? They heat the salt water, and then the fresh water, the water will evaporate, turn into a gas, and what's left is salt. And so then they'll condense that water, and then they'll have pure fresh water. So we do have a process to make fresh water from salt water, but it's too expensive. It's not worth it. Hey, if you want to become like some sort of millionaire, billionaire, figure out a quick and inexpensive way to remove the salt from salt water. Just, I'll take, some sort of credit in any way when you do figure that out. So a lot of our water in the United States comes from Alaska. And what about us getting water? Let's think about that for a minute. So we have a lot of our fresh water frozen in ice caps. Should we try to bring them to areas that need water? Can we do that? Let's try to remember something though. This world runs on money. If people who need water don't have the money, they're not going to get it. And that's sad. I'm not agreeing with that. I'm just saying that's how the world works. So we need to really think about how we do things. And we need to really petition our government officials for better quality of life for everybody. Here in this country too, we've dammed up the Colorado River, which is the river that goes through the Grand Canyon, which is what causes droughts in some parts of the western United States, because that river is being used to make hydroelectric power and isn't flowing to different places. Or we've brought water to Las Vegas. It's in the middle of the desert. It's not supposed to have water there, but we brought it there. So there's a lot that goes on that as you are getting older, you can kind of think about and realize and ask why we do those things. And if you don't like them, then hopefully we can make them change. Now, just to talk about this and bring in something that we're going to talk about, well, we have a lot of water frozen in ice caps. So there's a freshwater reservoir. Reservoir is a place where something is stored. But let's think about climate change. Those ice caps are going to start melting. And guess where it's going to go? Into the ocean and become more salt water. So I don't know, should we do something with those resources now? How can we do that? These are all things that scientists think about that you can think about. I want you to take some time and think about where do most pollutants in the ocean come from. You pause this video, look it up. I know the answer's right there, but think about what kind of pollution you think of in the ocean. Look up the Pacific Ocean Garbage Island. It's not exactly what it sounds like, but it is this huge and vast amount of plastic and garbage that's in our ocean. When we dissect seabirds, like an albatross or like a stork, inside of them, you know what you find? Plastic. If you were to dissect a sea turtle, you know what you find in it? Plastic. I forgot how much it was. I think it was at least 70 or 75% of ocean life that we've checked. We found plastic or microplastics in them. So what we do here affects things all over the world, affects animals. And you might be one of those people who's like, yeah, I don't really like sea turtles. I just don't care. Well, they fill a role, also called a niche in the environment. And we don't know what losing some of these creatures would do to throw off the balance of everything else. Again, that's just showing how everything is interconnected, living and non-living. So, in the United States, we have tried to pass some kinds of legislation to reduce the amount of pollution we put into the ocean. It's still happening. Why? There's more of us here than there were in 1990. So even if people are making less pollution per person, there's more people. There's more stuff. And just when we were talking about watersheds before, the largest one in the U.S. is the Mississippi River. Just kind of letting you know. So hopefully that helps you understand a little bit more about the water cycle, about why it's important to study these things. I know a lot of people say, why do we need to know about this? I'm not going to use this. This literally is your life. You need water or you're going to die. Even if you say, I don't drink water, that Mountain Dew that you're drinking, guess what? It's made out of is water. So we do need water. It's essential for all life on Earth. So you should know where it comes from, where it goes. Just look up Cotton Eye Joe. That way you can at least live what I had to live through in the 90s. And that way, when you are an adult and can vote, or if you want to run for office, you can say, hey, we need to do something about our water. This is so important. That's why you should learn about these things. So I hope that helps you understand a little bit more about water, about our resources, and about why environmental science is so important to study for everybody. All right, I hope it helps. Thanks. Bye.